Greetings, math friends. We are going to take a quadratic function and put it into the vertex form. So we kind of have the general quadratic form here for a function. This isn't set equal to 0, it's set equal to f of x. We're going to switch this over to y first of all to match the expectation of the vertex form. Right now, the expectation is that we can plug in any value for x and evaluate this and find that this plots the entire parabola. We're not specifically looking for a 0 of the function right now or a root of the quadratic. When you find the vertex form, it allows you to, at a glance, visually see where your vertex is for your parabola. This is a global maximum or minimum value for the function. So one of the things that we learn in Algebra 1 is that we can go from y to f of x to go from an equation of two variables to a function notation. So we're just reversing that. The next thing that we're going to use is a factoring technique. We want to look at the values that have the x's as a common factor and factor out the lead coefficient if it is not 1, because we are going to do a completing the square process in here. So that's a technique that we need to know. I also like to move this constant, the y-intercept, over to the side with the y, just to get it out of the way, to keep this from being visually cluttered. Some people will do this process with this constant out here, and that's fine, but I think it's helpful if you're just beginning to learn the process of converting to a vertex form to just push that value out of the way temporarily. So I've just subtracted the 6 on both sides, and I just want to focus here. And I'm going to divide this lead coefficient out of both of these terms. So I'm factoring that lead coefficient out. All right, now that I have that lead coefficient factored out, I want to complete the square inside this set of parentheses. So I'm going to be looking for the special c value that I can add in here to make this a perfect square. So that perfect square is going to have the form of c is going to be equal to the b value, that's this coefficient of this term, divided by 2 and then squared. The nice thing is that the b value that I have here is 1, so I'm going to take 1, divide by 2, and square it. So that's going to give me a quarter. If I add a quarter inside the parentheses here, I need to add something on the left-hand side of my equation, or I can no longer call this equal because I've adjusted one side and not the other. This is a catch for some people. I've added a quarter in the parentheses, but what I add to the other side is actually not a quarter. This quarter is being affected by the 5 because this is a scalar multiple over everything that is in parentheses. So I'm going to need to take 5 times 1/4, and that is the actual quantity that I've adjusted on the right-hand side that I need to adjust the left-hand side by. So I'm actually going to add 5/4 onto the left-hand side because I'm taking 5 times 1/4. Adding 5/4 onto the left-hand side now makes this a true equation because I've added 5/4 here and I've added 5/4 here. Now this 6 and 5/4 can be brought together because these are both real numbers, so we can just complete the addition process there. Over on the right-hand side, now that we have a complete square in parentheses, I'm going to rewrite this as a square term. Now that I've cleaned this up a bit and I've done the substitution, the last step that I need to do is add this 19/4 to the other side, and I will have my vertex form. So now I have a vertex form here. This is my h value and my k value. Now it should be noted that the signs are switched, so the vertex of my parabola actually occurs at -1/2 positive 19/4. So when you graph that, that's what you should see. The a value here is positive, which means that our parabola opens up. Hopefully this has been helpful in giving you an idea of the steps that you need to go through to convert from a quadratic function to its vertex form so that you can identify the vertex visually, or just because that's an exercise that you have to complete. Cheerful calculations.